All right, here we go. The final section of chapter 5. This is one of the major ones that makes people's heads pop off. So if you have trouble, let me know. There are four methods of solving exponential and logarithmic equations. Two are based in exponentials, and the other two are more based in the idea of logarithms. So the first two about exponentials are getting bases equal and taking the ln of both sides. The other ones are when the logarithms start showing up, so changing the logs to exponents and getting logs equal to each other. I'm going to give you examples of all of these. There will be an additional bonus video where you can see me just solving a bunch of problems. And you can watch that as much of that video as you want or as little of that video as you want. This video is all about giving you an example of each type. So my thing crashed, so you don't get to see that. Hang on. Okay, so here's our first actual one. So is getting the bases equal. Now, some of the identifiers for this one is that I don't see any logarithms. Again, these first two are based in exponentials. It is the first thing that you want to try to do because it is the easiest thing to do of all of our options. The idea is that if we can get these bases to be the same, then the exponents must also be the same. So I have 125 equals 5 to the x. So what I want is I want to try to get, I'm actually just a little terrified that that's going to crash, and it didn't crash, so that's okay. Not right now, Mel. So what we want to do is we want to get that 125 to be a 5 to the something. So I'm thinking in my head of what could be happening. So 5 squared, that's 25. That's not big enough. But 5 to the third equals 125. So I can replace this 125 with a 5 to the third. And then on the other side, we just have a 5 to the x. Since these bases are the same, we have a 5 and a 5, then these exponents need to be the same. If the bases match, the exponents match. So then this thing is solved. It's just 3 equals x. Easy one. Our next method is taking the natural log of both sides. Now this one looks very similar to the one that we just did. There are no logarithms, but we can't get the bases to match. You look at the bigger number 16 and you think about, okay, well, we want that 16 to be a 5 to the something, and I'm not quite sure what. Well, if I do 5 to the first, that's just 5, so that's not going to be big enough. If I do 5 squared, that's 25, and that's too big, and we've skipped over that 16. So I'm not going to very easily get those bases to match. Now, if we could, and we choose the ln of both sides, it will still work. We'll just get like a nice answer at the end, but for the most part, these should spit out gross answers. So that just means like, oh, I could have done this easier, and I made it harder on myself by taking the natural log of both sides. I won't fault you, but I will be like, oh, no, that's a bummer that you kind of wasted your time when you could have just gotten the bases the same. And that's about all that will really happen. So the idea with taking the natural log of both sides is you just take the natural log of both sides. So now we have the ln of 5 to the 3x equals the ln of 16. And what's cool about that is we can use that property of logarithms that if you have an exponent inside of a logarithm, like this 3x, you can bring it in front and get it out of the exponent, which was the major problem. We didn't really like that that thing was up in an exponent. Now it's just a regular old x that we can solve for. So now we just need to try to get that x by itself. So there's a couple things I need to get rid of. I need to get rid of the 3, so I better divide by 3. And I also have an ln of 5. ln of 5 is just a number like 3 is. So just the same way we would get rid of 3, we can get rid of the ln of 5. If you type it into your calculator, you get a number. So it's just a number. We're going to divide this also by 3 ln of 5. So x equals the ln of 16 over 3 times the ln of 5. And I should have said this at the beginning. this method is called taking the ln of both sides. You could technically take the log of both sides instead of the ln using common log. I like ln just because it's 2 letters instead of 3 letters, so it saves me a letter every time I write it. That's the only difference. With this one, I will often say give your answer to 3 decimal places, so I want to type this into my calculator. Hang on a second while I grab that. Now, to type this in, you want to be careful. Here's a common mistake. So I want to type the ln of 16. It's a common mistake. People do everything right here, but they don't type it into their calculator correctly. Then I want to make sure that 3 and the ln of 5 are in the denominator, so I need to make sure that they're wrapped up. If I don't wrap them up, then we're not going to get the correct answer. So I get 0.0542, which I'll round to 0.574. I don't think I said the right number. I was just reading off of my calculator. 0.574. That's done. Now, some of the common errors that happen is some of the parentheses things that I started to mention. One of the common errors is people will forget this parentheses around the denominator. So you can see we get a different answer. The reason is it's doing the ln of 16 divided by 3. Good. But then it's not dividing by the ln of 5. It is multiplying this quotient, the ln of 6 divided by 3, and then multiplying by the ln of 5. The ln of 5 is in this denominator. We want to divide by the ln of 5. Another common error is, and here, let me get back to that one, is not closing off this one. This is an actually even easier one to do because, okay, I've got to wrap up that denominator. It's really easy to forget that last parentheses. You can see this also gives us the wrong answer. It doesn't matter if you skip them at the end, and I think this is where that error kind of comes from, is the final parentheses. Your calculator can actually live without them. So see, I got the correct answer here. But this earlier one is important because otherwise all this ln stuff, it gets shoved inside of the other ln. So be mindful of our parentheses. This is the correct setup of it. You could also avoid that by just doing it in pieces. So doing like the ln of 16. Great, I've got that. I want to divide that by 3. I've got that. And then finally, I want to divide by the ln of 5. And then you can get that nice answer that we were looking for. So you can break it up into pieces if that makes your work a little bit easier. Okay. Next, and now this is our first one where we have logarithms show up. Now this one is one where we see only a single logarithm. So I don't see any more logarithms than that. I only have one logarithm. If you can get it down to just one logarithm, you want to translate that equation. You want to turn that logarithm into an exponential. So if we can change this thing into a logarithm, into an exponential, which we totally can, we'll be able to solve it. So I want to translate this thing. So this would translate to 3 to the 4th equals 9x over x minus 8. And now this is almost like a linear or something. So 3 to the 4th, I can actually figure that out. So I might as well just do it. That is 81 equals 9x over x minus 8. I've got an x in the denominator. I'd really like it out of there, so I'm going to multiply both sides by x minus 8. And these are all old solving methods, so like that we learned back in like chapter 1. So it's nothing logarithmic or exponential that's connected to it. It's just kind of like what this turned out to be after we did that first step. It's no longer an exponential one. Actually, I'm not going to multiply that, and I'll show you why. I'm going to be a little sneaky. So I got 81, x minus 8 equals 9x. See how there's that 9x and that 81? I really kind of want to get that x by itself. I'm going to clean up my problem a little bit and also make my distribution easier. I'm going to divide both sides by 9 just to make my life easier. So then I have 9x minus 8 equals x. So I've technically solved for x, but there's an x on the other side. So I got a little more work to do. So I'm going to distribute the 9 now. Now I don't have to do 81 times 8. I can just do 9 times 8. That's a lot easier. I would have divided by 9 eventually anyway. So 9x minus 72 equals x. So then subtract that x, so we get 8x minus 72 equals 0. I'll bring the 72 over. 8x equals 72. So x equals 9. And we're all set. So the actual exponential part was pretty easy. We just had to translate it into this. Everything we did down here was stuff from chapter 1. So that's just chapter 1 solving stuff that we did down in this part. Our final method that we've got to take a look at is getting the logs equal. So this is when you see more than one logarithm. In fact, I actually have 3 logarithms. So if I've got more than one logarithm, my goal is to get the logs equal to each other. It's the same thing with our exponentials. If we can get the logs the same, then their insides will be the same. So let's do it. I see 2 logarithms over here, though. I can put those together. If I've got 2 logarithms being added, I can multiply their insides together. So I get the ln of x plus 8. That's going to equal the other 2 being multiplied together. So I'll have just a single logarithm, ln, and I want to multiply these 2 insides together. So I need to do this x. I'm going to just do the distribute right away. X times x is x squared. And then this x times the 3 is going to be 3x, and there'll be a plus right there in the middle. Nice. Now that those logarithms are the same, I've got one log equaling another log, their insides are going to be the same. Sure, they're different. I've got this is an x plus 8, and this is a whole bunch of other stuff. But since I am taking the ln of both sides, I could imagine that I did the taking the ln of both sides step. So I can just undo that and just be left with what was inside of my 2 logarithms. Just like when we got the bases were equal, their exponents are equal. If the logs are equal, their insides are equal. So we have an x plus 8 equals x squared plus 3x. Now this is something that we can just solve like we did back in chapter 1. It's a good old quadratic. So I've got x squared. I'm going to subtract that x. So then I get a plus 2x. And then I'm going to subtract that 8. So I get minus 8. And then I bet we could factor that. So we get x. We can do positive 4 and negative 2. X plus 4. X minus 2 equals 0. So x could equal negative 4. Or x could equal 2. So we get 2 answers for this one, which is kind of interesting. But do we? Remember, logarithms can't take negative numbers or 0, particularly negative numbers. If I try to take this negative 4 and put it into the natural log, I can't do the natural log of negative 4. So this is actually an extraneous solution. We do get extraneous solutions with these. So make sure you check to make sure that your numbers are actually working. We can do the ln of 2 plus 8, that's 10, that's fine. I can do the ln of 2, that's fine. And I can do the ln of 2 plus 3, that's 5. I can do the ln of 5. So that should work out just fine. And those are all our methods. If you'd like to see additional examples of me working through all of these so you can see more of these solvings, there's an additional video. It's a bit longer to watch so that you can do all the solving stuff you need to. Okay? Thanks. Bye-bye.